Okay, this is section 5.2 of our Math Links textbook. These are questions related to gathering like terms. So before we start, we got to just refresh our idea of what like terms are. So like terms are algebraic terms. So if I said, first of all, we have to know what terms are. So if I said 4x squared, we would call that a term. And the reason why it's a term is because it's made up of the product of a number and a variable, or a variable product. So if we think about it, if I was to write this on repeated multiplication, it's 4 times x times x. If I had another term to it, like for example 3 x cubed, that term would be 3 multiplied by x multiplied by x multiplied by x. All right? So that would be those two terms. Now, add those together. In order for them to be like terms, the number type, which we'll call your coefficient, can be anything. It doesn't matter what those numbers are. However, the remainder of the term itself has to be identical to each other. So in this case, x squared is made up of an x times an x, and x cubed is made up of an x times an x times an x. So therefore, we would say that 4x squared and 3x cubed are not like terms. However, if we were to give you another two terms, for example, negative 2xy squared, and we were to give you 3xy squared, if we examine each of these two terms, this term would be negative 2 multiplied by x multiplied by y multiplied by y, plus 3 multiplied by x multiplied by y multiplied by y. So again, the coefficient character, those can be different. And the remainder of our term, x times y times y, x times y times y. So we would say these are like terms. And if we gather like terms, all we have to do, we're going to add them together. You have to combine your coefficients. The negative 2 and positive 3 makes it 1. Now we end up with, this is my answer, because we don't need one coefficient. They're unnecessary. Added those two terms together, or gathered or collected like terms, these two terms added together. Now, there's only one variation, just to show you one that kind of tricks up students sometimes. I said 2x squared y plus 3xy squared. Sometimes students think those are like terms, but if you examine the repeated multiplication, you see that they're not identical, because here we have the x squared is actually x times x times y, x squared y. This is x times y times y, so they are not like terms. As a result, we cannot gather them with y. Okay. With that said, that was a long preamble. When we get back to this first question, using models, show how you know that s and then minus 5s will combine to give you negative 4s. Well, like we said before, these are two terms, and you can either connect the two terms with addition or subtraction. In this case, it's subtraction. And it says using models. So when we talk about algebra tables, usually we make it into x, but we can make it an s as well. So that would represent this one. And the negative 5s, we're going to include that subtraction sign as part of the term, would be these here, right? 5 negative s. And if you think about algebraic real pairs, those value of those zero. So algebraically, just apply to call it an algebraic real pair, our solution, or what would be left over. In your second question, so G, or it was French name, you know, playing with 3n squared plus 4n could be combined to give you 7n cubed. Do you agree? It's like a pattern. So when you're dealing with 3n squared, just like I said in the last question, we know, based on what we just described in question 1, that these are not like terms, because this is 3 times n times n, and 4 times n. And in order for it to be like terms, the coefficients can be different, but the configuration of the variables has to be the same, so they're not the same. So therefore, that would be as far as we could combine these terms, talking about terms. If we wanted to draw it, an m squared is really connotating the area of the tile. So if I said this length is m, this width is m, the area of this particular one is m squared. All right. So rather than actually physically write out the length and the width and the area, we simply use a square and we represent that as being m squared. We have three of them. We look like this. And then with that, I'm going to add a positive 4m or 4m's. Again, the m is going to have a length of 1, the width of m, so area of m, m squared. And I have 4 of those. And we would say we cannot combine those two because they are not like this. We can't combine cats and dogs and get a cause. That's the next one. Because the one we'll look at that one is all most people would agree that 2 cats plus 5 cats is 7 cats, or 7 cats equals 2 cats plus 5 cats. Use this information to support our argument determination. We just did that there. Can't combine dogs with cats, or whatever. Question 4. There's a number in front of a variable affect whether or not you like to have those terms. So I'm using again, I'm just talking about that. So if I have this one and I have this one, they have different coefficients, but they have the same variable coefficient. So if I was to combine those two, I would end up with just combining my coefficients of -2 and 4, add those together, you get 2. Question 5, what is the value of the coefficient and the number of variables for each term? The coefficient here is -3, and the variable is z. -3 is the coefficient, and z is your variable. Now some people say, what's your variable? Some people say z squared is your variable, but z is your variable. Just happens to do it multiply together. Here, even though it's not written, your coefficient is 1, and your variable is k. And the last one, there is no coefficient in the term 43. 43 has no coefficient because it is constant terms. It is a variableless term that is usually added or subtracted from an algebraic term to create balanced equations. And there are no variables either, so 43 is that. Question 6, determine the value of the coefficient and the number of variables for each term. Here we go. We have 4 here. We use your variable. Here, different than the other one, we have a negative PRT. Sounds like a Michael Jackson. Pretty right. Your coefficient here, there appears to be none, but it's actually a -1 coefficient, right? -1 coefficient, and your variables are P, R, and T. Here you have a -8 coefficient, your variables are B, or F, and G. Question 7. Question 7. It says use the following monomial expressions which have a coefficient of 1. This has a coefficient of 1 even though it's not written. And this one has a coefficient of 1 even though it's not written. Which have 2 variables. This has 2 variables, P and S. And this has 2 variables, X and T. Some people might think this has 2 variables because X squared would be an X times an X. But it is only 1 X. It's not 2 X. It's not 2 X's, it's just 1. It's 1 variable. Which only have 1 variable with an exponent of 1. Well, this has a 1 variable, and this has 1 variable, but both those variables have exponents of 2, so they don't count. This has 1 variable with an exponent that's not written of 1, count that one. And this has an exponent of 1 that's not written. And finally, which has a coefficient of -1? Only one of those terms has a coefficient of -1. This one, and we don't write the one, we just treat it as a negative sign, or the opposite of PS. Question 8, identify all the like terms in question 2. So here we have a term with A, and another term over here with A. The coefficients are different. The variable configuration is the same, so those are like terms. So they are the only 2 like terms in A. B, coefficient of 3, variable of M. Coefficient of 4/3, coefficient or variable of M, so those are like terms. And in C, we have 6p squared and we have 1p squared, so those are like terms. But we also have 2 terms that do not have variables. We have a constant of -1.9 and a constant of 5. So those are different like terms. I would circle those in red instead of. So those are all the like terms. Again, in question 9, same question. We have a negative 2 coefficient with a variable k. We have a 104 coefficient with a variable k. Here we have a half coefficient with AB variable configuration. And we have a 1 coefficient. And then your last one, we have 13d squared, and we have 1d squared. Those are like terms. We have a negative 5 constant and a 5 constant. Collect like terms. So here we have a 4-term polynomial. Now, when you are presented with the question of collecting like terms, you have to make sure that even though this is the first term in my polynomial, x with an exponent of 1, it doesn't mean I gather the first. What I'm going to do here, Dane, is I'm going to look at the 4 terms and decide, of the 4 terms that are in this polynomial, which term has the highest degree. In this case, the term with the highest degree is my x squared. I'm going to include the subtraction sign with the term. I'm going to treat it like a negative 2x squared. I have another one over here. So the rule is, keep your x squared term and combine coefficients. So your negative 2 and negative 2 coefficients is going to make a negative 4 coefficient. So those two terms are going to combine to make negative 4x squared. And the 3x and the 1 more x is going to make 4x, so a positive 4x. So if you just put 4x down, that would be wrong. You need to combine them by putting plus positive 4x. And the simplification of that polynomial will be the binomial negative 4x squared plus 4x. Question number B. I have 5 terms in this polynomial. If I examine all 5 terms, the one with the highest degree will be my n squared. So I'm going to include that negative sign and I'm going to positive sign. And negative 2n squared and a positive 2n squared are going to make an algebraic 0 pair. So really, when I gather those 2 terms, they're going to cancel each other out and make nothing. We're going to not n squared and not gone. My next terms are going to gather are my n's, and that is going to be a negative 3n, not 3n, but negative 3n. So that's the first term in my collected polynomial. Then I'm going to gather the 2 constants, a negative 4 and a positive 3. So we have a negative 1. And the next question, q squared is my highest degree term, so I'm going to gather those first. A negative 4 and a positive 3 are going to make a negative 1. So I'm not going to write negative 1q squared, am I? I'm going to write what? Just negative q squared. That negative sign does represent a negative 1 coefficient. Call that the first one. My q's, I got a positive 2q and a negative 3q. When I combine those coefficients, it's a negative 1q. That's simply the negative q. And then when I combine my constants, a negative 2 and a positive 2 make nothing. So my simplification in ascending degree of terms is a negative q squared minus q. Question B, I only have 2 types of terms. I have constants and I have c terms. I combine the first one, negative 4c and a positive 5c. So we make a c. 3 and a negative 7 will make a negative 4, so that makes c minus 4. H squared and 4h squared make 5h squared. Positive 2h and negative 3h make a negative 1h. It's simply negative h. The 1 is not necessary to write. And finally, the last one, 2j squared and negative 3j squared combined, Johnny, to make a negative j squared and negative 1j squared. We will not include the coefficient of 1, which is the negative sign. 2j and 3j make 5. And finally, a negative 1 and a negative 5 make negative. There's your solution for those 6 questions. 11 is the same thing, so we're just going to go through it quickly. Negative 3d squared and positive d squared is going to make a negative 2d squared. Negative 5d and a positive 2d make a negative 3d. Y squared, which is positive, and negative 2y squared. Negative 1y squared, or simply negative y squared. A positive 2y and a positive 1y, positive 2y. can't gather it further because they're not like the same variable configuration. Now the next one is a 6-term polynomial. Gather my p's first. 4p squared and negative 3p squared. Going to make 1p squared. Negative p and positive 2p make 1p. And negative 5 and positive 3. M and 3m is 4m. 6 and negative 4 is negative 2. Oh, sorry, positive 2. We'll reverse 4m. 4m plus 2. 2q squared and q squared is 3q squared. Negative 3q and 1q, negative q, negative 4. And finally, the last one, positive w squared, negative 4w squared is negative 3w squared. Positive 5w, negative 2w is positive 3w. And negative 3, negative 1, negative 4. Which expressions are equivalent? So in this particular one, we are given the trinomial of negative 3x squared plus x minus 4. We are given 5 different polynomials that once collected may or may not be equivalent. So if you look at the first one, I have 3 terms. They are not arranged in descending degree of terms, so I'll rearrange them. My positive 3x squared will go first. My positive x will go second. My negative 4 will go third. I'm going to rearrange them. And when I compare it, they are almost identical, right? They are not equivalent, however, because this coefficient is negative 3 and this coefficient is positive 3. So we can say that those two are not equivalent expressions. In the second one, when I rearrange them, I'll take my negative 3x squared first. My negative 3x squared. My positive x, now notice the 1x I'm just going to keep there, my negative 4. When I write it that way, this is the same as the expression of it, so it is. If I look at my next one, my negative 4x squared and my 1x squared are going to make negative 3x squared when I combine my terms. My positive 3x and my negative 2x is positive 1x. And my negative 6 and my positive 2 make negative 4. It is also the same as my terms as the expression negative 3x plus 4. Here, I'm going to combine my x squareds here to get negative 3x squared. So far, we're looking good. My x is going to be by itself, which is looking good. And my negative 3 and my positive 1 are going to make it negative 2. Therefore, this is not equivalent. We're going to make negative 3x squared. So far, so good. Exciting. A positive 2x and a negative x makes a positive x. Ooh, we're still good. And a negative 2 and a negative 2 make a negative 4. Hercules. And finally, the last one, we have 3x squared. We have negative 3, positive 5, which makes 2x squared. And another negative 6 is going to make negative 4x squared. So right off the bat, I don't have to finish it, do I? Because I know when I gather my x squared, I end up with x squared, which is not going to be equivalent as the equivalent percent. Question 13 says Jessica and Dan are working on a measurement problem. Their calculation will help provide Jessica's question is 2 meters and 30 meters. Maybe I have to do this one? Question 14. Now we're going to skip that one. Oh, no, we won't. Describe a real-life situation that could be represented by each expression. So let's pretend you're all going to have different ones. I'm going to make M represent monkeys. Monkeys at a zoo. Monkeys at a zoo. So M represents the monkeys at a zoo on Tuesday. Now Wednesday, 3 monkeys died. Right, it was a terrible monkey accident. the peanuts that they were eating in the zoo were laced with salmonella and they died. So how many, what expression represents how many are on Wednesday? Well, there was M, but now there's N minus 3, so that would be an expression that represents the population of monkeys at the zoo on Wednesday. And for this one here, if P represents how many pineapples I buy. Pineapples I buy from Amazon. I'm going to order my pineapples from Amazon, and the cost per pineapple is $2. Okay, so a pineapple costs $2 on Amazon. What would this plus 5 represent, do you think?
The price not $5.
No.
5 extra.
Delivery fees.
Yes.
So if I'm going to buy pineapples from Amazon, they're going to charge me $5 for delivery. So if I bought 10 pineapples, how much would it cost me? $50. So if I bought 10 pineapples, how much would it cost me? No. It would cost me 2 multiplied by the 10 pineapples plus the $5 delivery. The pineapples themselves would cost me $20 plus $5. So the total cost would be $25. Question 15 says for each of the following polynomials, write an equivalent expression with 6 terms. Question 15 says for each of the following polynomials, write an equivalent expression with 6 terms. So there are infinite possibilities of a 6-term polynomial that is equivalent to this one. I'm going to give you one of them, most basic of all. So if I think about this one here, 2p squared. If I was to have a p squared, or 1p squared, plus an additional 1p squared, those 2 terms would be equivalent to the 1p squared. It's negative 3p, I could make it into a negative 4p plus p. Those 2 we combine. And our last one, the positive 2, we made up simply 1 plus 1. So now I have 6 terms in this polynomial, and if I gathered like terms, I would end up with this one here. With B, I do the same thing. So a negative 4x squared plus an x squared would make this term. I now have 2 terms to make up that one term. A positive 6x and a negative x would make this one. Negative 6x and a plus x. The negative 4 would make it a plus 5, and the negative 9. That would combine with negative 4. Those 6 terms would be equal to the final above it. Just like so. B. And finally, for C, 4r squared will make 5r squared minus r squared. That would be equivalent to that term. Minus 3q squared plus q squared would be negative 2q squared. And finally, minus 4qr plus 1qr. Those would be potential answers to equate that, but there are infinite possibilities. Question 16 says write an expression for the perimeter of each figure, then combine like terms if possible. Remember, perimeter is adding all the sides, or combining all sides, adding and combining the length of all sides. All sides. So in this particular shape here, I took this length here, which is 4d minus 5, and I combined it with d plus 7. I combined it with d, I combined it with d, I combined it with 3d plus 1. I would end up with 1, 2, 5, 6 terms that can be collected or gathered. 4d, 5d, 6d, 7d, 10d. Negative 5, positive 2, positive 3. Therefore, the perimeter of this particular shape would be 10d plus 3. In the second example, I won't bother rewriting it because it's already written down. W, and W is 2w. This is also a W. Nice. So those 4 W's would make 4w, or 4 times the length of W. plus an additional perimeter of this shape is 4W plus E. Question 17 is draw a figure with a perimeter that is represented by 5s plus 3s minus 2 plus s plus 6, where each value in parentheses represents the length of one side. So we really have three sides, which is a triangle. So I'm going to three sides. This appears to be the longest, so I'll do 5s again. This appears to be the next longest, so 5s s plus 6. If I simplify it, 3s and 5s and one more s, 9s, and minus 2 and plus 6 plus 4. So the perimeter as a simplified expression can be 9s plus 4. Question 18, a student council decides to raise money by organizing bonds. The cost of a band is $700, and the student council decides to sell tickets for $5 each. Write the expression for the profit that the student council would make, which is a variable representative. So remember, the ticket sales, money to make the ticket sales, take away the cost of the dance, or the band fee. Usually, where what you take at the door minus the cost of the band, that will equal your profit. Right? So if we make T represent the number of tickets sold, number of tickets. Then if they sell them for $5 each, the expression 5 multiply the number of tickets. If I sold 2 tickets, 5T would represent 10, which is how much money you would pay. So 10 tickets, 5 multiplied by 10 tickets, $50, which would be how much money you pay. So the algebraic expression 5T would represent the money you would generate from however many tickets you sold, minus the cost of the band, which is $700. So that expression, 5T minus 700, is the expression you use to calculate profit. So if you only sold one ticket, you would have made $5 at the door, minus your $700 to hire the band. You would have lost negative $695. If 250 students attend the dance, what is the profit? Well, you take your expression, substitute 250 for your T, and you would end up with $50 profit. Finally, estimate and calculate the minimum number of students who need to buy tickets for student council to make a profit. So, assuming that you made an algebraic equation, so if I take this equation of profit, and I want to make a profit of at least, let's say $0. Look at break even, or $0 break even. So I want to make no profit whatsoever. If I use this equation, I can isolate the variable to determine how many tickets I have to sell to make exactly no money. Divide both sides by 5. And T will equal 140. So if I sell 140 tickets, I will break even. I will make nothing. So therefore, if I sell more than, greater than 140 tickets, right? If I sell the tickets are going to be greater than 140, any number of tickets greater than 140, you will make profit. If you sell 141 tickets, you make $5. If you sold 200 tickets, you make $300 profit. Question 19, a heating company charges $60 per hour plus $54 for a service call, regardless of if we do anything, just for showing what we're doing, they're charging $54. So, write the expression that represents the total cost. Sorry. Yeah. So N is going to be the number of hours. So if it's $60 per hour, $60 multiplied by the number of hours worked will be what that guy makes, plus, regardless of how many hours you work, you're going to get $54. So that expression, $60 multiplied by the number of hours, plus the one-time service fee of $54 will be the cost of the job. Now, if it's 2 hours, You're going to substitute N for 2 hours. The total cost of the bill, 2 hours work, will be $174. And finally, it says the company charges half as much for a second technician. So the first technician plus the second technician will be the cost of having two. The first technician, I already determined to be this. The second technician, however, will be the same, except you're going to have half as much. Right? I'm assuming the service fee may be much. We'll see. So if I combine these two, this is still going to be 60 N plus 54. This one, I'm going to have half of 60 N and half a service fee cost. So the second technician is going to be $30 an hour. That's a service fee of, I'm assuming that's part of it, I'm not sure. $27 for service. Therefore, if I gather like terms, $90 per hour plus service fee of. Now, if you had a service fee here of 54, that's correct as well. I wouldn't mark that wrong. 90 times 90 plus $54. Depending on how you do it. And finally, the last question says publisher makes books for a number of distributors. One book for a distributor is represented by a fixed cost of $3,000 plus $16. So B represents the books. $16 multiplied by the number of books, that, plus, I still have to pay the publisher, sorry, that's $3,000. The expression was 16 plus 3,000. How much do 600 books cost? Well, $16 a book multiplied by the 600 books, plus a service fee for the publishing company to do it for you. 9,600 plus 1,000, $12,600. How much would 600 books cost if you wanted to buy from the publisher? It would cost you $12,600 to buy 600 copies of your book. And what would the cost of the book be at 600 a order? But since this is the cost of 600, divide that number by 600. Calculator, 12,600. Divided by 41 bucks. Okay. And what would the cost per book be at 1,000 per order? Here we would change this to 1,000. 16,000. We have 19,000. The cost of 1,000 books would go up to $19,000. And $19,000. Not doing well. I don't know why I'm doing this. Divided between the 1,000 books that you ordered, cost per book is $1,000.